This is 7.5. A dartboard has 8 equally sized slices numbered 1 through 8. Some are white, some are gray. A dart will be tossed and will land on a slice at random. What is the probability that the dart lands on a gray space? So there are 1, 2, 3, 4 of those. 4 out of 8 is 1/2. Okay. Now, we're going to learn about independence and dependence, and it's a little bit weird. So, if you don't understand, please ask and I'll explain it in as many ways as I need to. Letter B says, what is the probability that the dart lands on a gray slice given that the dart lands on an even numbered slice? So, whenever you see given, that means that something has already happened. Imagine that I throw the dart and I hit one of the spaces, but you can't see it. And I said, what is the probability that I hit a gray slice? Well, this is the answer, 1 in 2. Okay, so what if I throw the dart and I look at it and I say, the dart has hit an even number. You can't see it, but I tell you, the dart has hit an even number. What is the probability that the dart also hit a gray? So we're only looking at that one, this one, this one, and this one. What's the probability that the dart hit a gray? 1 out of 4. Okay. So we are going to talk about independence and dependence. This is called conditional probability. What is the probability given a particular condition? Okay. So if the probability of gray is equal to the probability of gray given anything else, like even, or the probability of gray given odd, or the probability of gray given the number is greater than 2. If all of those are the same, then we say that they are independent. If they are not the same, then we call them dependent, and it's kind of hard to figure out. Okay, so we're asking here, does the color depend on the number? Well, the probability of gray was 1/2. The probability of gray given even was 1/4. Does knowing something about the number influence the probability of the color? Yes, it did. So these would be called dependent. Does color depend on number? Yes, it does. But in this one, you don't have to do all of that. For each experiment, determine whether A and B are independent or dependent. The first one, a box contains tiles labeled A through Z. A tile is randomly chosen from the box and set aside. Then another random selection is made from the remaining tiles. So we have a bag here with a whole bunch of tiles in it. We reach in and we pull one out. What do we do with that tile? We set it down. Then we reach in and pull out another one and set it down. This is A, and this is B. Okay? So what is, event A is the first selection is a J. B, the second selection is a Z. Okay? Does tile B depend on tile A? Does choosing A affect the probability of B? Yes. Okay. Imagine the tiles were cards, And we wanted to know, what is the probability that this is the Queen of Hearts? How many ways can that happen? 1 out of 52. Okay? Well, what is the probability that this is the Queen of Clubs? 1 out of 51. So, did this card affect the probability of this card? Yes, it did. So those are dependent. The second card depends on the first card. What if this is the Queen of Hearts? What's the probability that this is the Queen of Hearts? If the first one is the Queen of Hearts, what's the probability that the second one is the Queen of Hearts? 0. That can't happen. So did the first card affect the second card? Yes. All right. A paper clip is randomly selected from a container with black clips and white clips. With black clips and white clips and thrown away. Then another random selection is made from the remaining clips. So A, the first selection is black. B, the second selection is white. Does the probability of the second one depend on the first one? Yes, because we're throwing them away. Does that make sense? So let's say there are 12 paper clips, 6 black and 6 white. What is the probability that the first one is black? 6 out of 12. We take that paper clip and we throw it away. What's the probability that the second one is white? 6 out of the remaining 11. Did this calculation get affected by that? Yes. What if I pick a paper clip, write down the color, and then stick it back in the jar? And then I reach in and pull out a second paper clip. Did the second one get affected by the first one? No. That would be independent. These are dependent. All right. A spinner with slices 1 through 8 is spun twice. The probability that the first lands on a 6 and then the second lands on a 5. Does spin 2 get affected by spin 1? No, not at all. No matter what happens on spin 1, spin 2 is unaffected. So those would be independent. Yeah, so what we say is, does B depend on A? So if it's affected, that means that it is dependent. If it is not affected, that means that it's independent. Deborah randomly selects one of her sports trading cards, then returns the card to the deck and mixes the deck and selects a second card. So is B dependent on A? No, because I stuck it back in. So the outcome of B is totally independent of the outcome of A. Last one. A bag contains red beans and orange beans. A bean is selected from the bag and dropped back into the bag, and then a second selection is made. Does event B depend on event A? No. I stuck it back in. So those would be independent. Okay. A math class has 4 girls and 4 boys in the 7th grade and 1 girl and 3 boys in the 8th grade. The teacher randomly selects a 7th grader and an 8th grader from the class for a competition. What is the probability that the students she selects are both boys? Okay. So we have 2 spots. What is the probability? So this is going to be a 7th grader, and this is going to be an 8th grader. So the class has 4 girls and 4 boys in 7th grade, 1 girl and 3 boys in 8th grade. What is the probability that the first person picked is a boy? Well, we're choosing from here. So it would be 4 out of 8, which is 1/2. Now, does the selection of the 8th graders depend on the selection of the 7th graders? No, they don't. So our second choice is going to be among those. What is the probability of getting a boy? 3 out of 4. We times those together and we get 3/8. So you have a 3/8 chance of getting a boy in both selections. Okay, let's do another one of those. All right. So the first box has 1 pencil and 4 pens. The second box is 2 pencils and 2 crayons. What is the probability of getting a pen in the first box? That would be 4 out of 5 times a crayon in the second would be 1/2. So that would be 4 out of 10 or 2 out of 5. Those are independent. This draw has nothing to do with that draw. Let's see if I can get a different one. No. Okay, I'm going to change this problem. Okay. So I am drawing from this box, and I'm going to draw twice. I will have a first draw and a second draw. What is the chance that they are both pencils? Well, when I reach into the box, what is the chance that the first draw is a pencil? There are 7 pencils, and there are 8 total items. If I leave that out, that pencil out, and I redraw, does draw 2 depend on draw 1? Yes. There are fewer pencils in the box than there used to be. Right? Do you guys get that? So when I reach in the second time, there are only 6 pencils left, and now there are only 7 items in the box. So those are going to cancel. This would be a 2 and a 3 and a 4. So I have a 3 and 4 chance of getting 2 pencils. Okay. A disc jockey has 7 songs for the playlist, 3 rock, 2 reggae, and 2 country songs. What is the probability the first song is reggae and the second is a rock song? So I'm playing 2 songs. What is the chance that song 1 is from the reggae? So that would be 2 out of 7. Does the selection of song number 1 influence the selection of song number 2? Yes. They're not going to play the same song twice. So for the second song to be a rock song, there are 3 of those. And now instead of 7, we have 6. Multiply that out, 6 over 42, which is 1/7. An automobile manufacturer produces 35 vehicles, 12 trucks, 9 motorcycles, 14 sedans. So we're going to select 2 vehicles at random. What is the probability that the first... what is the probability that 2 trucks are selected? So 12 out of 35 for the first truck. And then, can I pick the same truck twice? No. It says selected from the remaining vehicles. So what is the probability of getting a truck on selection 2? Well, 1 truck has already been chosen, so there are only 11 trucks left. And how many vehicles are left? 34. And so you multiply that out and you'll get a decimal, and it wants the decimal answer. All right. A factory that produces pistons for cars. Machine 1 had 585 satisfactory pistons and 315 unsatisfactory. Machine 2 produces 728 satisfactory and 182 unsatisfactory. So we need to find the total. So I need to add those together. 585 plus 315 is 900. And then 728 and 182 is 910. 728, 182 is 910. Okay. So what is the probability of machine 1 being unsatisfactory and machine 2 being satisfactory? So that would be 315 out of 900. Okay. And then 728 over 910. Does this depend on that? No. Machine 2 has nothing to do with machine 1. So these would be independent. So you would just multiply that out. 315 times 728 divided by 900 divided by 910. And I get 0.28. So you have a 28% chance of that happening. Okay. For each set of probabilities, determine whether A and B are independent or dependent. Okay. In order to be independent, so there are two ways to check. If A times B is equal to A and B, then they are independent. So if the probability of A times the probability of B is equal to the probability of A and B, then they are independent. If that is not true, they are dependent. Okay. If the probability of A, so if you have the probability of A and you add it, no, that's not how we want to say that. If the probability of A, how do I want to say this so it'll make sense? So A, B given A, if the probability of A is equal to the probability of A given B, then they are independent. If that's not true, then they're dependent. So if the probability of A is the same as the probability of A given B, then they are independent. So let me make sure I explain that in the right way. Okay, so if probability of A times the probability of B is equal to, okay, I got it right, then those are independent. And then this says if the probability of A given B is the probability of A, then they are independent. And the same is true of the B's. So if we look up here, we don't even need this. All we need is that. If the probability of A is the same as the probability of B given A, then they are independent. So this one would be independent. And this one, we look here, is the probability of B the same as the probability of B given A? Yes, so they would be, or no, so they would be dependent. And then this one, we just look here. The probability of A is the same as the probability of A given B. Okay. A fair dice is rolled 5 times. What is the probability that a 5 is obtained on at least one of the rolls? Okay. Oh man, this is a hard one. Huh. I wonder how they're going to do this. Ooh, that's messy. I'm gonna. That's a little advanced for this class. I'm gonna get rid of that one. I'm just going to choose 13 worms at random. Ooh, wow. They're not making these easy. Yep, I'm getting rid of both of those. Okay, get to work.